Everyone, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about work and also the expression to find out work done. Today let's discuss about energy. As you know, life is impossible without energy. The demand for energy is ever increasing. Where do we get energy from? The sun is the biggest natural source of energy to us. Many of our natural sources or many of our energy sources are derived from the sun. We can also get energy from the nuclei of atoms, from the interior of the earth, and from the tides. Can you think of other sources of energy? Yeah, infinite sources of energies are there. Now, the word energy is very often used in our daily life, but in science we give it a definite and precise meaning. Let us consider the following example. When a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. Similarly, an object when raised to a certain height gets the capability to do work. You must have seen that when a hammer is raised and when it falls on a nail placed on a piece of wood, it drives the nail into the wood. We have also observed children winding a toy, and when the toy is placed on the floor, it starts to move. When a balloon is filled with air and when we press it, we notice a change in its shape. As long as we press it gently, it can come back to its original shape when the force is withdrawn. However, if we press the balloon hard, it can even explode, producing a blasting sound. In all these examples, the objects acquire through different means the capability of doing work. An object having a capability to do work is said to possess energy. The object which does the work loses its energy, and the object on which the work is done gains energy. Okay, so let's discuss about energy. An object having a capability to do work is said to possess energy, which is very clear from the previous examples that I have cited just now. The object which does work loses its energy, and in accordance with the law of conservation of energy, the object on which work is done gains energy. We will discuss about the law of conservation of energy in our coming sessions. The energy possessed by an object is thus measured in terms of its capacity of doing work. Okay, so the unit of energy is therefore same as that of work. Unit of work is joule, so unit of energy is also joule, and energy is the capability or capacity to do work. There are different forms of energy. One is mechanical, another one is thermal, another one is electrical, and another is light, and the last one is sound. So these are the different forms of energy which is available in nature. Okay. Mechanical energy can be further divided into kinetic energy and potential energy. So there are different forms of energy, and mechanical energy is one among them. That mechanical energy can be further divided into kinetic energy and potential energy. So today we will discuss about kinetic energy in detail. So what do you mean by kinetic energy? Kinetic energy is the energy possessed by an object due to its motion. Okay, so whenever an object is moving, it possesses a form of energy which is known as kinetic energy. Now, let's derive an expression for kinetic energy. So for that, we know that force F is equal to ma, mass into acceleration. And also we had studied one expression, that is Newton's third equation of motion, v square minus u square equal to 2as. If the body starts from rest, then u equal to 0. That means if the body starts from rest, what does it mean? It means that the object is at rest initially. So initial velocity u will be 0. Then here when you substitute u equal to 0, you will get v square equal to 2as. Then what is s? Then from this s is equal to v square by 2a. That is what is written here. Now energy. Okay, I told you energy is the work done itself, right? So energy is the work done itself. And what is work done? Work done is force into displacement. WD means work done, and that is equal to force into displacement. And what is force? Force is mass into acceleration. What is displacement? See from the previous slide, displacement s is equal to v square by 2a. So just substitute v square by 2a here instead of s. Okay, and this acceleration a and this acceleration a will be cancelled. So we are left with mv square by 2 or half mv square. So what is the expression for kinetic energy? It is half mv square. Okay, so kinetic energy can also be denoted like this, E suffix k. E suffix k means kinetic energy, and expression is half mv square, where m is the mass of the object, v is the velocity of the object. And here when velocity of the object v is equal to 0, then kinetic energy E suffix k is equal to 0. Okay, so kinetic energy is 0 when velocity of the object is 0. So this is the expression to find out kinetic energy, half mv square. And what do you mean by kinetic energy? Kinetic energy is the energy possessed by a moving object, or it is the energy possessed by virtue of its motion. Okay, you know that a moving object can do work. An object moving faster can do more work than an identical object moving relatively slow. Okay, so just consider the examples of moving bullet, blowing wind, a rotating wave. All these objects which are moving with high velocity can do work, isn't it? A moving bullet can pierce into some object, so it is doing some work. A blowing wind can do anything, so it is capable to do some work. So, you know, how does a bullet pierce the target? How does the wind moves the blades of a windmill? So all these things, all these moving objects which possess a definite velocity are capable to do some work. So they are able, or they possess some energy, and we can call this energy as kinetic energy. Again, a falling coconut, a speeding car, a rolling stone, a flying aircraft, flowing water, blowing wind, running athlete, etc. all possess kinetic energy. In short, kinetic energy is the energy possessed by an object due to its motion, and the kinetic energy of an object increases with its speed. Okay, kinetic energy of an object increases with its speed. When the velocity increases, kinetic energy also increases. So that's all about kinetic energy. Always remember this expression. Kinetic energy is equal to half mv square, and the unit of kinetic energy is joule. Okay. With this, I am concluding my session. Notes of the topic and YouTube video have been uploaded. Please go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.